Hello, everyone. The Ankido training team extends a warm welcome to you. We are thrilled to have you join us today for our webinar on oil well performance. My name is Mohammed, and I'll be your host for this session. The webinar will be presented by our speaker, Mr. Mohammed Al-Jawhar. Mr. Mohammed Al-Jawhar is a senior petroleum engineer with demonstrated expertise in petroleum engineering, production management, and the development of strategic action plans. He excels in streamlining processes, delivering innovative solutions, and identifying new opportunities. Skilled in risk mitigation, he consistently generates and reviews approximately 20 job initiation documents and 15 statements of requirements each year to ensure efficient workflows. With a comprehensive understanding of engineering and production protocols, procedures, and best practices, Mr. Al-Jawhar is an effective communicator who builds strong relationships with team members, senior leadership, and stakeholders. Before we begin, here are a few quick housekeeping notes. If you have any questions during the presentation, please type them into the Q&A box, and we will address them during the question and answer session at the end. Please be aware that this session is being recorded. Throughout the presentation, we will share links in the chat box that will enable you to connect with Enkido Training on LinkedIn, Facebook, WhatsApp, and YouTube. The link for the certificate registration form will be provided at the end of the presentation. Certificates will be issued based on the information received through this link only. Please join me in welcoming Mr. Mohammed Al-Jawhar. Mr. Mohammed, please feel free to introduce yourself in detail. The floor is yours.
Thank you, Doctor, for your introduction. And I would like to thank you all for attending this free webinar. Hopefully, it will be enjoyed through this webinar and enjoy the information will be provided. Our webinar is about oil well performance. Before that, I would like to introduce myself. I'm Mohammed Al-Jawhar. I have 23 years experience in oil and gas industry. I joined the oil and gas industry since 2001 in PVT lab and worked a couple of departments through petroleum engineering, reservoir engineering, and working with multidisciplinary team. Worked with the BP staff, etc. In one of the largest field in the world, which is Rumaila, and other fields in Iraq. And now working in engineering and inspection department and asset integrity. It's a short brief. So all the things Doctor have said that. Thank you very much for attending. So let's deep into our session today about oil well performance. So what we will go to discuss today, this is the agenda. You can see it. We'll go through introduction to oil performance through these topics and ending with maintenance and workover considerations. So hopefully to get some idea about every one of it, and let's discuss starting with the introduction to the oil well performance. So introduction to the oil well performance. Building our discussion about the oil well performance, we will grasping the pre-drilling preparations, well planning, and drilling process, We know it's crucial for successful outcomes. Each stage from completion to ongoing operations affects not just the immediate yield, but also long-term productivity. And the so the well basics, it will include and is essential to comprehend the fundamental components that ensure effective extraction. So understanding the oil well structure starts with key parts such as wellhead, of course, where all the surface equipment is mounted, enabling control over the flow of oil and gas. Casing plays a crucial role in providing the integrity for the structure of the well, while analyzing well performance. Various factors such as geological conditions, equipment quality, and operation efficiency must be considered, all of which I will dive deeper into on the next slide about the well performance. So let's continue. So drilling, we know drilling, we have to understand the complex machinery involved, from the rigs, the people, experienced people, how the people was trained working in this environment, starting from the pressure gauge and valves, etc. The pre-training they was given to them is critical for effective drilling and extraction. So drilling involve many risks from starting from the first day to the deliver of the well. So pre-drilling preparation are essential for successful drilling operation. Gathering geological data through surveys and sample collections can identify optimal drilling location. So pre-drilling preparation, let's take example. So conducting this geological survey is very crucial for the selecting of the well the location. And this groundwork aids in assessing rock and soil characteristics, ultimately influencing site selection. Uh, Go further for well planning and design. So it's most important factor, not just the technical specification, but also safety and environmental impacts based on gathered data. This is creating a detailed well plan. It's vital for minimizing risk during drillings. So it's very important to know the casing well trajectory, what is the target depth for our well, and taking, of course, the considerations of the environment. Sometimes we are targeting some formations which consist of gases like H2S, and the safety of the people working there is crucial as the surrounded environment of the well site. So these will goes under the well planning and design, of course. So drilling the well, starting from putting the rig inside on the site, and starting from the first day of drilling the well, penetrating the surface, going to the target formation, and circulating the muds, everything else. So it's a very complicated procedure and taking time and cost effective, of course, throughout this phase. Well completion, we know well completion is considering installing casing and cementing the sand face between the casing and the formation is very crucial, and perforating the well, where we should perforate, and what is the type of the casing, etc. This will have to be done through all the calculation provided to complete the well in perfect way. Otherwise, we have a problem regarding the collapse maybe for the casing if we don't select the material it's related to the exact formation. Finished from the drilling. So after that, we have to consider the production, of course. So the first flow from the well, what should be installed in terms of the Christmas tree, the flow lines, what is the pumps needed maybe for this production, oil producer, how to optimize the production afterwards and optimize the recovery from the reservoir for that specific well. So post-drilling operations is very important because we need to know is that well performance as we expected from the first day of planning the site through the drilling and finishing the drilling and delivering that well and connected to the production. So monitoring production rates and reservoir pressure, etc., is very important to assess what is the well is doing. So these kind of procedures and process have to be followed to ensure the well performance is as we expected. So let's go to the one of the fundamentals about oil well components. So we know for sure there must be a Christmas tree and wellhead installed, and these parts is connected together to seal. Should be sealed. There is no any space, and what is these parts should be installed and why. How many valves should be installed, and what the type of the well, what is the operating pressure, etc. All these equipments should be installed perfectly, and it's very crucial. So understanding oil well basics leads us to the fundamental components essential for well operation: the tubing head, spool, etc. The tubing adapters serves as crucial interface between the wellhead and the production equipment, while the casing head housing supports the weight of the casing sealed the annulus. The casing spool is vital for properly sealing the casing and providing connection for other equipment, so facilitating pressure management. The tubing head spool, on the other hand, connects the tubing wellhead while maintaining an effective seal. So all these equipments should be selected carefully to, in a good manner. And we know we have to know why we install these type of equipments on the Christmas tree and the wellhead. It depends on the flow within the well system. So let's look at this production integrated asset system, starting from the ending with the degassing. So what we have to consider, and why is it what question should be asked regarding this production system, why we installed this Christmas tree, where we are going to produce from annulus, is it from tubing? So why we have to put like this Y piece? What is the surface equipment will be installed? So the choke size, the gate valve, safety valve, the gate valve. What is the length of the production pipe? What is the diameter of that production pipe? How many valves will be installed through the way to the degassing station? What is the inclinations? We know some pipes have some inclination through the way from the well to the degassing. So that's maybe affect the flow from the first of beginning of from the well till the end of the degassing station. So when this the flow reaches the degassing station, connected, is it to high pressure header or to low pressure header? Why maybe can asking like these questions? Sometimes we found of course it's related to the oil well performance. Sometimes we've noticed some wells it's in front of a high performance well, while our well it's this side it's low performance well. So we've seen some of example where the wells cannot flow perfectly through the header to the manifold and through to the degassing. So we have to consider where it should be connected to the maybe high pressure manifold or low pressure manifold. It's depend on the well performance, of course. And we have to see what is the well through our software and the simulation, what is the performance of the well. Then we have to consider all these surface equipments, sizes, and material regarding the oil production, of course. So this can be illustrates the complete somehow the complete system of integrated asset system for the production. So the type of check valve, why we need to install like this, we have to consider it very well. Is it fully open, partially opened? We need to monitor, of course, the pressures up and down, cross the choke, through the choke. I mean, the differential what we have to consider in regarding the well performance. So all these kind of question maybe can arise. Why we install it? What's the consideration to install all these type of equipments from the Christmas tree till the degassing station itself. And of course, it's all connected together as a one system. So every point we have to consider the pressure, temperature, etc., and the factors playing around the well performance. So if we take starting talking about factors affecting oil well performance, let's take this illustration. So from this illustration, we can find starting from reservoir where the hydrocarbon can flow through this porous media to the wellbore, and then to the wellhead, and finally to the degassing station. So we have a couple of delta P's here. So what is the delta P's represent? It represents loss in reservoir pressure, loss cross completion, loss in tubing, in flow line. There is a total pressure loss. So we have all these kind of information should be considered when we have trying to studying the factors affecting the well performance. So starting from reservoir characteristics, which is porosity for sure, permeability, what is the fluid properties playing here and affecting the flow from the our reservoir through the wellbore. What is the operational condition? Do we have a pump installed? What is the pump efficiency? What is the depth of the well? We know some wells with higher depth, maybe depend on the perforation, depend on the reservoir, can be not easily extracted the hydrocarbon because of the depth, because of the high pressure, or maybe some circumstances can be affecting the fluid column here, and that maybe because we have a back pressure from the gravity, hold-up factors, flow regimes, etc. All these kind of consideration regarding operational conditions definitely impact the well performance. So we don't have to forget the environmental factors, which is the temperature and geological of the reservoir, of course, which be have to be studied very well because sometimes we have not continuous, for instance, not continuous reservoirs, so we can have not all the hydrocarbon moving freely from the reserve to the inside the wellbore and getting what we have to expect other will do. So back again to reservoir characteristics, which is fluid properties. We know the fluid properties playing a crucial and vital role in reservoir and in the well performance. So we have a question here. Can the fluid properties change over time? What is the answer? Yeah, it can be changed. So for example, for instance, taking the viscosity or GR, water cut. So from the first day, we can expect these type of values is constant, and then we can it could be changed through the time. So when it's changed from what expected and then it's changed, we have to consider new rules for the well performance, and so we have to manage techniques such as water shutoff, EOR, regular monitoring, extra monitoring, and what is it possible to keep it as it is, or what is the mitigation regarding these type of information changed through the well performance oil life. So yeah, all these kind of questions has to be raised and have to be studied very well from the reservoir engineers regarding the well performance, and that's very important. For instance, when we have a wax started to form asphaltene content, paraffin content, what is the oil water cuts sorry, the water produced from that well? Is it what is the amount of that percentage of the water produced from the well? Is it how is it affecting the well performance, etc.? So these kind of questions can be raised and have to be carefully answered and studied very well to know each stage of the well performance, what value has been changed to the new value. So to optimize well management, techniques like water shutoff and enhanced oil recovery must be employed alongside regular monitoring. So monitoring the well performance is very crucial for that. Why? This ensures that operations adapt to the changing characteristics of the reservoir. So this is very important aspect, of course. So analyzing well production data. We know the production data, it's very important. It's like the eye of the engineers are working in monitoring the well performance. So what is the collection and compilation of that data? So starting from gathering production data, organizing the data, and validate data quality. So these steps, very important, very, very important. So taking the example of collecting the data, for it's what the well is doing in terms of oil or water, or what is the PSW for that well. Then we have to put it in structured database. So it's crucial to establish effective data collection and compilation process. First, consistent daily records of oil, gas, water production are essential. This includes the gathering of all relevant production data to ensure comprehensive insight. Once we gather it, it's necessary data we must compile into a centralized database. So the database is very important. We will go through some in a moment, some slides about the data and what the visualization of that data. So addressing issues like insufficient well test, incorrect entities, entries, or bad routing information, ensuring high data quality. So eliminating these kind of errors, we will have an in data validating data quality. So the data quality is very important. How we make sure the data we have it's relevant and Q and QAC for that data. So the data lays the groundwork for the analyzing production trends. So we'll look at what's the production trends in a moment. So production trends analysis. So after we collecting the data and validating a production data, the next step is conducting a thorough production trend analysis. What does that mean? This involves examining historical data to uncover fluctuations and patterns that may not be immediately apparent. So sometimes we have to keep eye on the production data to eliminate any uncertainties and discussing why we have like these trends and fluctuations and patterns. So identifying these production patterns is crucial as it aids in recognizing inefficiencies in well operations, such as issues with maybe pumps, or maybe there's a blockages, stopping the well producing as it could be. So if we consider the plateau rate is 10,000 MBD, why the decreasing pressure in oil performance and reaching like these about 1 or less than 1 MBD. So what is the mitigation to back the well as it is? What is the plan to restore the production from the well? So utilizing statistical models can enhance predictive capabilities. So we have to going to forecast future production and how should our well producing through its life for future production levels. So forecasting based on historical trends allow us to adjust operations proactively, thereby optimizing our production strategies moving forward. So optimize production strategies is depend what we have already collect as a data, monitor the well performance, production performance, and predict what should be doing through the oil well life. And then we have the optimization production strategies to adjust operation based on that production trend what we have. So identifying production patterns. Let's take a look at this illustration. So let's take this example. So after reaching this high amount of production, monthly oil rate, we have seen this trend going down from 25 to almost 5-6 MBD. So there's a huge difference in production trend. Why we have like these anomalies in production? It's regarding the time frame. Is it 1 year, 2 year, and why it's going down? So is there any potential to restore the production? Yes, definitely yes. So how we can assess that production trend? We going back to the historical data we have, cumulative production, and see what is going on here. What is the production enhancements should be done. So understanding these trends, the operators can identify where is to tweak operation parameters, such as maybe if we, for instance, if we have ESPs installed, so we can manage these ESPs and restore the production from that wells, or maybe we have do some extra work as a surveillance and do a workover or adding perforation, etc. As we have the reserves in the ground. So these kind of things we have to monitor very well, very closely, to see what is the pattern is doing for exact well. So for if we have seen the higher rate now, it's back again to unexpected production. So why is it regulating from like cycling from high to low, high to low? What's the reason behind these cycling production rates through the time? So is it the taking the time we have to after prediction we've done, is that possible to be predict, or is it out of our prediction? So what is the trend tell us? It's tell us there's a certain plugs maybe at the reservoir, inside the wellbore, or maybe some facilities not performing well. So we can restore the production again after we managing on removing the disease restriction from flow lines, for instance, changing some parts of the for the completion, changing the tubing size, for instance, installing something, or add perforation, or maybe acidizing the well, and to have like nice production again from the well. Take another example, taking another example of well performance plot. So we have, as have you said, that there's maybe a problem not in the well, but it's related for the facilities itself. So there's a vessel problems, maybe flex line leak. So this affecting our production. So maybe this leak or the vessel problems not related to the oil itself. So we have to, from these trends and these plots, nice plots, we can discuss with the production engineer and where facilities engineers, and see where the problem is and how we can mitigate these problems and removing the risk again to the normal condition of nice production. So let's see, we can see there's a huge difference between what we have and what we get afterwards. And maybe with the help of our calculations, we can understand where is the problem is, and we can deep further and our investigation to check where the underperforming happened and why. So maybe not relating to the well itself, maybe it's relating to another facilities connected to our well. So underperforming maybe not related to the well itself. Another thing we have to consider, and it's very important, it's forecasting future production. So if we have like for instance, this plot, and we can see where could be the potential to restore production, where could be there's a high water cut, maybe have it from the production inside from the well as it's performed. Maybe there is a gas breakthrough, water breakthrough. There is aquifer not supporting our reservoir, that's leading to underperforming of our well. So we have to do our prediction, and to know where we can enhance production, where we have maybe enhance the reservoir pressure. So is this point, it's very crucial in terms of forecasting future production. So identifying the bottlenecks in our performance for the well, and the predictive analysis can suggest where we can adding more oil or restore production for the rest of the oil life. So maybe having said that, there's a equipment failure. There's something related to the reservoir itself, permeability issues, skin issues, anything else. We have to know exactly where we can address these problems and how to mitigate these problems. So optimizing production strategies. For instance, let's take these examples. What's our software can tell us. So flowing through tubing annulus, we can see from the plot, it's unstable condition. So what we can do, we can maybe converting from tubing annulus to annulus. It's more stable. Yeah, there's a nice plot here. So we have to see what is the parameters after outcomes from converting the tubing annulus flow to the annulus flow. So what is the regarding VLP IPR? What is it? It can tell us, is it stable or not? So if we have stability for a long time, maybe it's not stable on annulus, so maybe can convert back to the tubing flow and see our annular flow, keep it on annular flow again, and see how nice our IPR VLP is regarding the PWF and our reservoir pressure. Regarding the water cut, we have what is the GOR represent here. So all these parameters after putting in our software that can tell us, and after plotting the IPR VLP can tell us what is the optimum flow rate we have to expect from our well. And this is very important because we need the well flowing for a long time period with a stable condition. So fluctuations like these trends of plots, it's not acceptable, because if we exceeding the amount of excessive production, I mean, maybe can affecting the well performance, and maybe we can lose the well, of course. So matching the points with well test, maybe we can't conduct a well test to matching the well test with our predictive analysis can build optimization production strategies very well and perfectly match what we can expect from the well as a performance for a long time without any trouble with fluctuations of and losing the well performance. So for what we have from our trends, we can extracted some points of maybe there's incorrect reading. It should be considered, because some incorrect reading may be feed it inside our software. So these readings can maybe, for instance, if we have a high water cut, just suddenly we've seen it, and without backing to the history of the water cut, and maybe this incorrect reading without QAQC for that data and feeding it into our software can maybe leading to another problem with regarding the well performance. So taking the wrong decision regarding unrealistic data, maybe the collection or collecting of that type of data is not as it should be planned, and not following all the procedure should be taken to consider collecting that data, leading to unexpected errors, and then we can feed it again into our software, and we have a wrong decision making. We've seen like these fluctuations in our modeling with a wrong decision afterwards. So what we have nowadays, the new technologies implemented in our fields. So considering the current VLP-IPR in the flow, it's critical to embrace automated monitoring system for effective production management. These systems enable real-time data. So connecting our wells to our softwares and the analytical system, we have to track of well reservoir performance, facilitating immediate adjustment. So we've seen many examples where, sorry, for the well performance, we have conduct a fast decision making and implement a new strategies to mitigate the risk of losing the well, because this avoiding reservoir damage such as excessive drawdown leading to issues like coning or sand production. This preventive strategy ensures long-term recovery stability. So integrating smart well technology, well, of course, with the real-time monitoring capabilities, elevates our operational efficiency. It's very important, very crucial, and very handy nowadays. We've seen as an end user, you have all the data instantly presenting on your screen, so you can decide where the problem is, how to mitigate that problem. So allowing for adjustments across varying reservoir zones, moving forward for a nice performance of our well. So this is eventually ending with evaluating well productivity in a good manner. So evaluating well productivity index calculation. We know it's very important to know the well productivity index. So how the well is producing is crucial to understanding how to optimize extraction methods. So the productivity index calculation measures the relationship between production rates and pressure drawdown in reservoir. This helps quantify well efficiency by assessing how effectively the well converts reservoir energy into fluid production. So moving from unstable flow to stable flow, where's the maximum point we can reach, how we can, for instance, taking this plot as plot between the Q and pressure, so we can build the good relationship between the pressure and production, what is going on inside the well and reservoir. So having said that, well converts reservoir energy into fluid production. It's a key factor that impacts well productivity, include maybe permeability and skin effect, which can alter flow characteristics. By assessing reservoir condition, we can identify opportunities to enhance performance of our well and maximize output, as we have to remove like these skin and eliminating these factors, which is reduce the well productivity and minimizing the well production performance, because we have like these situations. So it's to identify the opportunity to enhance performance and maximize output, because we've seen a good performance and then going down. So we need to optimize our production. So this consists to production efficiency, which will deliver into the actual versus potential production rates. So how we can do that? We have to monitor all these kind of factors, which is of course contributing to the well efficiency. So what is the key concepts in quantifying oil well efficiency? So understanding production efficiency PE is crucial, as it represents how a well is performing against its ideal capacity. So moving from Q1 to Q2, why we have like Q2? So what is the pressure? Why we have like this declining in the pressure? Is it good for the health of our well or not? So high PE maybe suggest efficient operations that maximize output, reflecting minimal downtime and optimal management. So conversely, low PE, which is production efficiency, the actual production rate, theoretical or over the theoretical or potential production rate, can give us that need in addressing, such as mechanical failure, maybe, we don't know, or reservoir challenges. The significance of mechanical efficiency lies. We have to move to mechanical efficiency, which is useful energy output over the input of energy. This can be the percentage of the mechanical efficiency for our well or our equipment of the protection equipment, I mean, which should be vigilant about signs of inefficiency to avoid costly repairs and operation losses. So recognizing these metrics sets the stage for discussing volumetric efficiency, which is measure actual fluid production against theoretical expectation and linked to effective reservoir management. So we running some tool to investigate our well through what is the casing situation, what is the tubing situation, do we have any anomalies in regarding that, can identify if we have any something related to the mechanical efficiency. So the volumetric efficiency, of course, it's actual fluid volume produced over the theoretical fluid volume. So maybe we have our software tell us something about what should be expected, and the actual it's something different because we have produced more water or maybe more gas compared to what we have in theoretical situation. So what has to be done, how to mitigate these things? So continuing from production efficiency, volumetric efficiency plays a vital role in understanding the performance of the well. It is defined as the ratio of the actual volume of fluid produced compared to the theoretical, as we've said, which indicates how the hydrocarbons are being extracted. So this is the volume efficiency. So it's very important to know what is the volume metric efficiency for our well, and that can be done by our simulation software. The metric is crucial for evaluating the effectiveness of our extraction methods and reservoir characteristics. So it's very important to know how is the well is doing, because otherwise we can miss some data and not conducting predictive analysis to for our well and our reservoir. So missing some parts cannot give us the actual fluid, and we have not in rewards development efficiency. So reservoir recovery efficiency express the percentage of initially placed in reservoir that can be economically extracted. It underscores the importance of reservoir properties and production techniques. So emphasizing that the role of enhanced oil recovery methods as we look ahead. So another factor, recovery efficiency. So do we met the goals from the first place when we have our plan, how much we have to extract, what is the initial oil in place, what is the cumulative production afterwards, comparing these values and having the recovery efficiency is very important because most of the companies looking after the recovery efficiency. So that can tell us how we doing through our well performance. So we don't know we do know now if the reservoir performance is good, and that's reflecting our well performance, of course. Taking some key points about assessing the reservoir condition. So it is, and we know the role plays by the skin factor, and how can that skin relate effective role in terms of permeability near the wellbore. So we're having some issues, and most of the time we're having maybe mud filtrate or something skin damage skin regarding our production. Excessive production maybe can damage the reservoir near the wellbore, and then we have with the unwanted drawdown between the reservoir and our wellbore, and then that affect our production from the well. Maybe the damage caused by injection. So the injected water is not compatible with our formation. That's make plugging the boreholes near the wellbore, and that can affect the continuity of the hydrocarbon flowing from the reservoir through our wellbore. So these fine plugs affecting the formation near the wellbore and causing damage to our formation, and these damages can affect, of course, the outcome. I mean, the production performance of our well. So production optimization, going back to this concept, we have to consider where we're starting, which reservoir pressure, and how that reservoir depleted through the time. So what is the performance for each time? So we have to consider it each time, and when we can maybe intersect with our VLP, and then we have VLP IPR intersection, and then we have our predicted performance. I mean, the flow rate of our for the optimal production rate. We have considered through putting these values for our pressure. So starting maybe from this first place initial pressure, and the drawdown continuously through the year of the well of the reservoir, and how that can affect the well performance of our liquid rate from our well. So these inflow and outflow curves can predict and can be predicted and can be measured, calculated through our software, and then we have the outcome, how the well is performed. So these kind of values we have to put considerably for instance, the saturation pressure, what can be happened when we have a gas breakthrough, because we may be producing below the saturation pressure, and we don't know how that can affect our well performance. So we have to be avoiding like these points to keep the well in terms of IPR VLP intersection and in the region where the safe flow rate. Again, with the optimization opportunities. So identifying production bottlenecks. So for instance, if we take this example, we've seen the preferred flow path, it's through tubing. Actually, our software tell us this is not the optimum flow pattern we have to put the well in it. So maybe converting from tubing to annulus or tubing annulus will give us more stable condition. So identifying these bottlenecks is very important. Otherwise, we can maybe lose the well suddenly, and that's happened a lot after deep consideration and analyzing the bottlenecks. These kind of problems has been mitigated and removed because we know exactly what is the flow path, for instance, has to be put for instance, for another reason, the flow line has restriction. So why the flow line has restrictions? This kind of questions can be raised and have to be studied well. Is the flow line size is not compatible what the well is doing? So maybe this can be a bottleneck for our production from the optimum performance for our well, and has to be removed, and mitigation is to be changed, or when the well, for instance, for the flow line system, is it from the beginning of the flow line, is it near the station, or all the flow line has some area where we have converting from maybe from 6-inch to 4-inch, or from 4-inch to 8-inch. What is the pipeline diameter? And that may be restricting the flow line from our in the output. We have an uncomfortable plot. Comfortable by low performance production from our well. Another example for the optimization opportunities, of course, it's ESP. So enhanced artificial lift system. So how we can enhance the production from our ESPs? We know these nice area where the ESP can perform very well. So we are avoiding from being here or here and the optimal production for our SP have to keep in the performance inside this yellow area, so not underperforming, overperforming. It's very important to optimize how we can do that through our optimization of our artificial lift system. Optimizing the injection strategies as well is very important. So how much we have to inject? What is the rate to be injected in our reservoir? What is the recovery factor we have reached? How that can maybe improve the reservoir pressure? How many wells? What is the injection pattern we have to follow? All the strategies relating to the injection. If we have already injected, we injecting water inside our reservoir, or injecting gas or another type of material inside our reservoir to reduce the effect of losing pressure from our reservoir, and that will affect, of course, the well performance. Reservoir characteristics and impact. So what does that mean? Porosity and permeability, of course. So we know the crucial role played by the porosity and permeability, how that influence the well performance and reservoir performance and well performance afterwards. We have seen some issues with the skin factor, how we can mitigate this skin factor related by acidizing, for instance, maybe to remove like these unwanted parameters. So building on reservoir characteristics, we delve into the specific properties that directly influence our production. So we know the porosity and permeability, which is critical in determining the volume of hydrocarbon in reservoir can hold and their ease of movement. So these two parameters is very important, crucial for our movement of our hydrocarbon to the wellbore. So high porosity means high storage capacity, while increased permeability facilities, fluid flow, and extraction efficiency. And the fluid composition, of course, examining how the varying ratios of oil, gas, and water can alter well performance. So if we have higher water cuts, definitely that will raise the gravity inside the wellbore and the column of the of the fluid inside the wellbore, and then we can that reduce the production from our wellbore from our well. So for instance, high water cut saturation can impair production rates. So, and then the interplay of reservoir pressure and temperature is crucial, as these factors significantly affect productivity, influencing phase behavior of the fluids. These properties and performance aspects set the stage for understanding geological factors affecting production rates inside our reservoir and then from our well. So what are the geological factors? We know the reservoir characteristics can be one of the crucial factors playing in the well performance. The depth of the reservoir significantly impacts both production rates and recovery efficiency. So the depth is playing this fact playing in the performance of the well. Greater depths maybe can complicate the extraction process due increased pressure and temperature. The permeability of rock influences fluid movement within the reservoir. So maybe high permeability allows oil and gas to flow more. If we move to the permeability issues, more freely inside the wellbore, enhancing recovery rates. Whereas low permeability, of course, we know can restrict flow and pose challenges for production. Fractures patterns within the rock can create pathways for fluid movements. So unwanted fractures inside our reservoir maybe can hold the reserve moving from our reservoir to the wellbore, and we have not continuous flowing because it's affecting by these pathways created by these fractures. So affecting both the speed and volume of extraction. These kind of things can be considered when we have to drill our wells on the spot well locations where we have to be drilled, and where because sometimes these can affect our production from our wells. Artificial lift system and performance. Pump efficiency. We know we already talked about pump efficiency. So measuring the pump efficiency is very important. Why? Because if we don't have the right parameters for our pump from the VSD, hertz, and ampere running the motor, maybe we have a higher temperature affecting our performance of our ESP installed in our wells. This can maybe lead to need to evaluate the system efficiency to ensure optimal operation and performance. This involves, of course, measuring pump performance and analyzing energy usage consistently to identify areas for improvement. So this threshold has not to be so in being in this area on this area over performance, under performance of the well running by ESP can lead to fail ESP, and we have to pull it after putting install workover rig, and that costs money and time, of course. Lift efficiency, we have to consider the intake pressure and discharge pressure through the performance as the performance of our ESP, and This lift efficiency metric allows us to evaluate whether the system meets its intended performance goals, where we have to, in this performance, I mean, the goal of the performance of our well. So based on hydraulic design and operation parameters, and we need another to take in consideration, it's the energy consumption by our artificial lift and the power requirements for artificial lift. This can be unnecessary expenditure and implement changes that can lead to significant savings for our ESP and putting overload or maybe pump efficiency is underperforming, and we don't have the head capacity as should be for our artificial lift. So optimizing techniques. So for instance, taking the right stages for the ESP for what we consider the depth of our well, where is it perforated, how much can produce, what the stages needed to maximize production through our ESP. So, and putting the right performance through the well performance plot of our ESP that can maybe minimize energy consumption because we have a less requirement of power because the well is our artificial lift in the optimum curve location. So the optimal performance of our ESP in good condition. So we don't have to think about the friction between stages or the higher production rate, and then we have more corrosion because of the erosion velocity, etc. These kind of higher temperature, higher pressure, higher ampere, leading to higher temperature inside our ESP, and then underperforming of our ESP. So how these kind of questions we can to analyze to extend our life of our lifespan of our ESP, because we have to when we need to consider maybe flush the ESP to remove any restriction inside the ESP. So this kind of these things can be done to restore the production and put the performance again in the optimum location and inside the well performance of our ASPs. Maintenance and workover consideration. Back again to one of the most important factors and plots, it's the analyzing production data. So if we consider this plot where we have like this train going down, why it's going down, why the well performance not performing as we expected, how from these kind of trends, what can be expected in terms of underperforming wells? Is it something related to the well itself? Is something related, as we've seen, from the facilities? It's related for the reservoir. What is the mitigation we have to remove to remove these kind of problems inside our for our well performance? So what's a type of strategy to have to follow to inspect surface equipment, for instance? If we see like these pictures, maybe there's for definitely there is a problem relating corrosion in our for this well. We have to close it. Sometimes it's not being noticed from the first time, and that can lead to a huge impact on the environment and the well itself. So scheduling routine maintenance is very important. We have to check all these type of valves installed for the Christmas tree. Is it performing well? There's no leaks. inside, or how we can check, as we seen inside the well bore itself, running some tools like, for instance, multifungal caliper to see if we have any corrosion or related reducing in thickness inside the well bore, maybe from any type of data we have from these trends, maybe the well starting producing water cut, this water or gas breakthrough can lead, for instance, some kind of like these problems. So how we can mitigate these things through our maintenance program. So workover planning execution, very important. Taking the notice from these graphs where the problem is for these like unstable conditions for some wells. So we have to identify some optimization production to identify where the wells it's underperforming, and then how we can make the workover planning and how we can execute these workover programming planning for those wells to reduce or eliminate these kind of risks from the producing wells. So mitigation of these risks may be, for instance, if this interval it's producing more water or more gas, can we put a packer and keep producing from other perforation? And if that's happen again, maybe put another packer, and maybe we do an intelligent completion, producing from this perforation and producing from this perforation from other tubing, close and open when we need it. So this kind of workover programming planning should be done beforehand to after understanding what is the well is doing. So sometimes we need to maximize the efficiency of our wells. Some wells have lateral drilling, and that can be for another reservoir from the one well. So that can maybe minimize the drilling cost and effectively maximize the efficiency of recovery from our reservoir through different layers. So these kind of things can be planned beforehand and studied very well regarding the well performance, if we need to keep the well performance as long as should be. For instance, if we consider this well is producing from this formation and do these kind of lateral drilling for another formation. So after that, maybe the well performance well produced before that from this formation 1 or 2 MBD, we can add more of 2 or 3 MBD from another formation and extend the production life for the well itself, and maximizing the recovery factor and production for the field itself. So improving overall reliability is very important. We've seen the preventive maintenance should be done effectively and in time manner to address where the problem is. So some part of the Christmas tree maybe or inside the wellbore has to be do some maintenance for it. So preventive maintenance will tell us exactly where the problem is, when it should be scheduled. Scheduling these type of remediation, it's very important to keep the well performance as should be, and we have to put it inside our agenda for next pair of, for instance, these lower and upper master valve, for instance, for this example. Or maybe we have to remove some parts and put another parts to remove these kind of problems, because these kind of valves consider a second barrier for our wells. So when we do any surveillance for our wells, can be if we have one barrier, it's different from we have two barriers regarding the safety issues. So workover planning strategies maybe can included water shutoff, can be injection capabilities, reservoir pressures, maybe uh, equipment uh, changing. So any type of data we have to input in our cover program, like soil water disposal capacity, obligatory consents, etc. It has to be done through our cover planning for our wells. And lastly, the equipment upgrades. So sometimes we need to upgrade some equipments installed for our wells. For instance, we can change this YPC, or maybe change some valves, or changing the inside wellbore from maybe the tubing size, or we can install liner hanger, or etc. So upgrading these equipments for the wellbore, or the Christmas tree, it's important. Maybe we need to change the choke size to because the well it's underperforming. So we've reached the end of this webinar. Thank you very much for your patience, and hopefully we have a good webinar delivered to you.
Okay, Mr. Muhammad, thank you for your presentation on oil well performance and for joining Enkido Training's webinar series once again. Now, I think we have a question in the chat box. So let's head over to the chat box to review the questions and address them.
Okay, let me check. Mm.
There is a question about the reservoir, how the reservoir depth can impact the well performance, from Sarah.
Yeah, having mentioned that, reservoir depth can be affected by increasing the pressure and temperature inside the wellbore, and that increase the head column inside the wellbore, and this the head column inside the wellbore increase the reverse pressure on the liquid coming up to the surface by there's another factor of friction, hold up factor, and gravity.
Okay, maybe someone has any question. Please, the attendees, if you have any question, you can raise your hand and we can allow you to open your mic. Okay, Mr. Muhammad, on behalf of the attendees, maybe I can ask you two questions. The first one, sometimes we see the pressure difference between the reservoir pressure and the bottom hole flowing pressure. The term of reservoir pressure can be expressed as follows. P sub E, external pressure, sometimes average pressure, P sub AV G dot, and sometimes PR. What is the difference between of them?
Yeah, sometimes we refer to the initial pressure for the reservoir, or reservoir formation pressure. So it depends on what we have to which formula we have to use. For example, if we use the Vogel formula or Darcy formula, the pressure itself it's we have maybe it's small I, so that mean initial pressure for our reservoir when from starting the beginning of the production.
Okay. And the second question about the difference between absolute open flow AOF and the Qmax. What is the difference between two terms?
Yeah, that's a good question. So it's regarding the IPR. When we study the IPR for the our well, it's absolute open flow. It's mean there is no inside PWF. So there is no wellbore flow, pressure inside the wellbore. So it's from the reservoir to the surface. So it's zero pressure. So it's zero pressure. So we have only reservoir pressure. And the other factor when we have Q maximum, when we have PWF, so what we can expect from our well to produce if we have a differential pressure between the reservoir pressure and the wellbore pressure, flowing pressure.
Okay. I think there is a question, another a question. How can we develop better use of produced water in field operations and well productivity? This is from David Martinez, this question.
Um,
In the chat box, please.
Let me check. How we can develop better use of produced water. So better use of the produced water is very a good question. So nowadays, some of the companies re-inject this water inside the reservoir again. So we don't marked as wastewater. So this wastewater can be rejected into the reservoir to enhance reservoir pressure after purifying this water because we need to this water to be compatible with our reservoir.
Okay. And there is another question, sometimes from Ahmed Basil. You can read it, please. Sometime while
Sometimes
drilling.
while
Yes.
drilling, the pressure is up. What is the problem and how we can be fixed it? So it's depend on the targeted formation. So why we have drilling pressure going up because sometimes we've seen that's why they put the equipment of to prevent blowout. So they sometimes there is a kick from the reservoir itself and depends on the reservoir parameters have to be studied carefully before the drilling operation implemented.
Okay. Mr. Muhammad, I think we need to make other webinars about production engineering on our reservoir engineering or maybe some workshops with you because of the requesting of our attendees. And I think there is a question in solution gas drive low pressure support in the future. How IPR can be predicted from Muhammad Mansour.
In salute. Sorry, let me go back. Low reservoir. Oh, so it's depends on the what kind of prediction you have in your hand. So what strategy of prediction you have follow. I mean the prediction itself related to what is the strategy of the reservoir depletion. So we can help by predicting inflow performance relationship, IPR and solution gas drive. or we have to see where we have the low reservoir support from our reservoir when we have a gas drive. So it depends on the injection or the gas cap inside the reservoir, where is it can be extended in term of our oil performance.
Okay, that's great. Okay. That's all, Mr. Muhammad. At the conclusion of today's webinar on oil well performance, dear attendees, thank you for joining Aikido training today. We hope you found the session both informative and engaging. We look forward to welcoming you at future events. Mr. Muhammad, the Aikido training team appreciates your efforts and your engaging presentation. Have a wonderful day and goodbye.
Thank you very much. Thank you for all of the attendees to attend this webinar. Thank you again.
Thank you. Bye.